So despite progress that humanity has made over the last century, many children still die globally. And that is because of poverty and unequal access to resources. Now, part of the problem is that communities might be trapped in so-called poverty traps. Now, to analyze poverty traps, we need a lot of data across different dimensions of poverty. So for example, here you see access to drinking water that we can characterize to exist in different levels. So the very poorest exist in level 1, where they have no access to water in their household, but have to move or travel far to find clean and safe water. Whereas if you compare it to different other dimensions, you see the same type of levels of difference over time. Now, if we look at the global population distribution, we see that there are about 7 billion individuals on this planet, a bit more today, but about 1/7 of them live in these living conditions that you see here listed on level 1, whereas the richest, which is what we are used to in the Western world, is level 4 type of living conditions. To analyze the causes and consequences of poverty, we need, as I said, a lot of data. We need these Y variables that exist in different dimensions. Now, because of the lack of geotemporal data on poverty, scholarship is generally limited on the causes of why people are stuck in these poverty traps. So what we do at the AI and Global Development Lab is that we combine AI, Earth observations, and social sciences to analyze the consequences and causes of global development, both historically, geographically, and globally. So our lab currently is generating such data by combining these different disciplines. So what you see here is the city of Cape Town, and what we are capitalizing in this variation of development within cities. So from 1984 to 2018 and 2020, you see these large developments that are occurring within cities. And this is exactly the variation that we are capitalizing on. So the problem here is that what we do, and how do we do this? Well, basically we have these points that are survey points that we gather from existing surveys. We then stack them on top of this gridded map that designate the different levels of poverty or wealth. The goal is to create this map to the right that you see, that is this heat map. We then temporally stack these slices of data on top of each other. We train a machine learning algorithm on the points where there are survey points that we know. We then use the algorithm to impute where the red line is, to gather and see how development has occurred over time in space. So developing an algorithm for poverty measurement is one of the goals that we have embarked on. So what we have here is basically this F is the algorithm of interest. For countries such as now Burundi, where we don't have data at certain time points, we impute or give the satellite images for this function, and then we generate these maps that are generating Google Earth Engine. So the structure of the algorithm is roughly like you see here, where there's these temporal stacked models. You give it impute images, daylight images, nightlight images, processes through the algorithm, out comes a prediction, and then we connect these with different layers so that the algorithm learns what happens over time in space. So without our project, basically we'll be stuck with, for Burundi, we'll do this for the whole Africa, that you have only 2 time points where there are household surveys that exist that we can use. But with our model, with our projects, with our model that we train, we are able to impute this series of data that is then our data product that we will release to the community. So in the end, we'll create these living condition maps or poverty maps that are hosted on Google Earth Engine, but also we can download them for further analysis and different statistical packages. And what we are doing basically here is the goal, as I said, is to train this model, then use this model for analyzing the causes and consequences of poverty. The approach is combining deep learning and different ground truth models from demographic and health surveys combined with Landsat satellite images. And we, at the current moment, have generated these data that live on our website, but also on Google Earth Engine. And we are in the process of developing these models further. Thank you very much.